Good morning and evening to the folks who across the globe who has joined this Airflow Summit. We are immensely happy to be a part of this, and I would like to talk about the data flow with Airflow at PayPal. At the end of the talk, I can ensure that you guys will have a fair idea on how to productionalize your Airflow instance and make it serve in a bigger and a better way. And along the course of the journey, I would take you through on how we are moving away from other enterprise schedulers to the open source Airflow. Would like to take up questions at the end, as Sumit just mentioned. So, the agenda for the day, I would like to talk about the motivation on why we are doing this, the use cases that we serve, a glimpse on our architecture and as well our deployment model, and finally about the APIs and operators that we built on the top of Airflow that will help us to cater to the wide range of use cases that we have. Now, a little bit about myself. So, I work as a senior software engineer at PayPal India. I have hands on experience in Scala and Python and have been a core member in building several products for PayPal in the data domain. Apart from work, you would find me either reading books or speaking at conferences or meetups like these. So, moving forward, now, a common problem that all of us would face when we start to think about the data extraction, transformation, and loading is that there are a lot of tasks and a lot of dependencies as well. Performing these tasks at the right intervals, at the right amount of time and space becomes the key of the entire data transformation pipelines. And suddenly there would be an increase in data velocity, and the cost of fixing those broken data connections itself will be a nightmare, taking hours of man time. And I'm sure any engineer or people in the DevOps space would have undergone this if you are working closely in the data space. So, we are living in an era where in God we trust and we all others have to bring data to prove their points. Because without data, we will just be another person with an opinion. So, making just sense out of the data to gain some information is not enough these days. We need insights out of the data to make data driven decisions. And this all boils down to a point where we need to declutter without using any additional resources. In fact, with as minimal resources as possible. Now, as we talk about ETL, there are tons of tools that can help us do it. And here is an example where you have a phone of two different varieties. With both of these help you do the same job, the ease of use and the additional benefits that you will gain will force us to adapt to the latest. Same goes in the ETL space as well, where we have simple things even like a cron that can schedule a job for you. But as it gets very complicated when we have to scale our systems. And obviously, that's one of the reasons why we wanted to move to something new and also efficient. But again, we were presented with multiple options, and there was a dilemma on which will suit best for our use cases. Uzi or Lugi or Airflow, or indeed the tons of other things that we evaluated before we wanted to venture into Airflow full time. So later, we pursued with revolutionizing our data platforms with Airflow. And as all of us are now stuck at home, tools like Google and Slack have become our only solace. And be it the other peripheral items that we come across, like Walmart or Spotify to buy essentials or just relax, one common thing that comes across all of these tech giants is their ability to efficiently process data and show us the favorite recommendations. And that's when our brightest and smartest kid, Airflow, comes into picture. When so many companies have already built their rails, and that's when we decided that hey, we could also venture into the data space using Airflow and see how it works for our data transformation workloads. So that was the start of the story. And we wanted to provide scheduler as a service. I'm a part of the platforms team where we provide services to the other internal domains for enabling them to achieve their business use cases. And one such thing was scheduler as a service, which was powered out of other schedulers that I would talk about until today. And we were shifting the workloads to Airflow. There are tons of reasons, as you could just go ahead, read online or resources that are available. Airflow is best in its own ways for tons of reasons. But I would just like to talk about three major things which was our driving factor behind moving to Airflow. So fault tolerance is something that will enable a system to continue operating in the event of a failure, even for when some of its components are down. And since airflow can be configured to be distributed naturally, it becomes resilient towards the common pitfalls and also provides a very amazing monitoring capabilities via its UI, along with some alerting for failures and SLA misses, which was very important compared to the rest of the schedulers or the workflow management tools that are available. And the concept of having DAGs or a directed acyclic graph, where you have a collection of all the tasks you want to run, organized in a way that reflects their relationships and dependencies, was very impressive. They allow for a previously long brittle jobs to be broken down into small granular parts that are more safer and more modular to be reusable. And Airflow lets you create pipelines that can be configuration as a code, Python, which lets you writing code that can instantiate pipelines dynamically. This comes very handy when you have large volumes of data and you need to deal with them. Now, what is the scale that we are talking about here? Any system can work fine when it is small, but the game begins when you have a huge amount of workloads and then you just don't know how you are going to deal with things like that, where robustness will go for a toss if the underlying system is not capable of taking it up. So that's why we wanted to give a glimpse of our scale so that it gives you guys a bigger picture. So we are here talking about some X million executions per day, some 100K unique jobs that are going to be supported by the platform. And underlying, we have some 10 different big data technologies where Airflow is going to do your transformation and loading across your Hadoop, Spark, Hive, and Teradata in this Teradata space. So that is where I'm coming from. And then what are the use cases that we cater to? So we have some very critical financial system files that we need to send to the banks at the end of every day that is payments critical. We also have some daily merchant reports that needs to be sent across the transactions made via our platform. Using big data technologies and analytics space, marketers can mine, combine, and analyze both of their data sets in a near real time way. This could help them discover some hidden patterns, such as different groups of customers that interact, and how this can lead to purchase decisions. All these are something that are powered out of Airflow, and there are also some fraud detection mechanisms for compliance that get scheduled periodically at every day for us to identify the scams associated with the system. So this is just a high level overview on the use cases that we are talking about. Now, let me just deep dive into our architecture. As always, this is just a core of whatever the Airflow offers today with a little bit of preferences of what we chose. So we have a web UI and we have a web server that will serve the request, a scheduler. The database that we wanted to use was MySQL, and the queue that we wanted to use was Redis. And as I was mentioning, distributed nature was something that we wanted to pursue. Salary workers were the ones that we picked up, and that would help us distribute and run the jobs across different virtual machines. NAS, or the network attached storage, in other words, is a shared file system where we place our DAGs and the logs that are generated out of Airflow, and the DAGs for any that will enable you to schedule. So, in a real world, there can be situations where a dip in performance of your systems might make your servers go down and ranging a spike of traffic and can lead to a sudden power outage too. It can worsen as your servers can be crippled, and irrespective of whether your applications are hosted in a cloud or a physical machine, such situations are unavoidable. However, rather than hoping that it does not occur, when what you should actually do is to gear up so that your systems don't encounter failure. And the answer to the problem is the use of a high availability configuration or architecture is an approach of defining components of a system which ensures optimal performance even at times of high loads. Although there are no fixed rules of implementing HA systems, there are generally a few good practices that one must follow so that you can gain most out of the least resources. And here, the main concept that we adhered to was redundancy and disaster recovery as we speak about the high availability. And especially when you are planning to productionalize Airflow, I would request you guys to sincerely think about how to make the infrastructure as such highly available and also geographically spread regions for our failover systems. So, as you could see in the diagram, the first place where you have a load balancer for your web servers, and then you have a, and Airflow doesn't recommend having more than one scheduler for your given use case because it might at sometimes lead into some concurrency issues. So what we did is to have a primary and a passive active primary scheduler and a passive secondary scheduler, and you have a failover system that could periodically check your heartbeat of your primary, and then when first it tries to restart, and if it fails it switches to the secondary scheduler as its primary one. The second one is obviously the, or essentially the external system that you would want to pay a very closer attention, is where the DB comes into picture, where in your Airflow connection string we will have the VIP of the MySQL load balancer that is being configured, and then internally it will point to read for both the databases while it allows write only for one of them. So your primary would be the one that is taking up writes. But if at all there is any issue with your primary database for some reason, or some data center issues, or could be tons of other reasons, your secondary is switched as your read and write only a DB, and then your queries and the writes will start taking place over from there. And the other thing is about the shared file system that we had, which we call as NAS, or which could be any other PVCs that are associated with your system. You also have redundancies for that, where you have a primary NAS and also a secondary as your fallback. And the queues that we had is your Redis. The same goes with the way I was talking about for the scheduler, where it is basically more of a failover, one active with another passive. And then you have a set of workers that are being associated for your given use case, which, like, even if one goes down, your other system should be able to take care of such a feature. So this is a very high level view of how this entire high availability architecture is going to look like. And then, like, there were several nitty-gritties that would come into picture of, hey, what if my scheduler is taking up a request at that point of time? What is the web server doing? Like, do you do a flush and things like that, which has been taken care as a part of the implementation details. Now, moving forward, scaling Airflow. A system is considered scalable when it doesn't need to be redesigned to maintain some effective performance during or after a steep increase in workload. So, workload could refer to simultaneous users or storage capacity or the maximum number of transactions that could be handled, or anything that pushes the system past its original capacity. And Google found that 61% of users won't give an app a second chance if they had a first bad experience, and 40% might just directly go to a competitor's product. So it becomes very important that we know the art and knack of scaling a system where it's going to work for you at any point of time, be it whether it is a normal case or be it otherwise. So that's when I would like to talk about scaling in two different ways, which is going to be vertically and horizontally. What does vertical scaling means? You can actually add more executors per worker. And what does horizontally mean? You can add more workers to the cluster. So it essentially looks something like how you see in the diagram, where you should be able to handle both of these use cases at a very simpler way. Now, so we also went ahead with the concept of clustering the Airflow. That is basically we wanted to split out our instances and cluster them based on their use cases. We started isolating the critical workloads with the best computes and the redundancies. Later, we have some workloads that execute remotely from America's West Coast to East Coast servers or something like that. So we split the Airflow instances in such a way that they can be configured geographically. And if we know that some are just going to be analytical use cases that can run for a few hours, we put them up in a low cost hardware and made it run for a few hours, where near real time requirements are not mandatory. And apparently, as we also split the Airflow instances based on the type of jobs that are being done, say one dedicated cluster for Spark jobs, one dedicated cluster for Teradata jobs, because that's when we can maintain a homogeneous queue and handle them accordingly. At this point of time, I would like to also emphasize on the kind of the hardware requirements that you are putting into place for Airflow. Say, for example, if it is very critical, ensure that it's going to have maximum redundancies, and you give a good amount of CPU and RAM that could be associated to your workers, so that they would be able to demand, like, so that they would be able to process the workloads at a better pace. Because there were several instances where by mistake, if someone, like, as we keep scaling the vertical scaling and the horizontal scaling that I was talking about. You keep adding more workers, and at that point of time, when you're provisioning a VM, and by mistake, if there is going to be an heterogeneous queue between your cluster, where there are certain workers at some config and the remaining set of workers and in the another set of configurations, that was creating a lot of problems, and that is something that we should never be doing. And within a cluster, it is always better to maintain a proper skew, and also split your airflow instances for different kind of workloads. This is just something that we did over here, but whatever works best for your particular use cases, you can just pick it up and then split them accordingly, so that all your scheduler latency delays and things like that can be avoided. Now, let me just talk about a little bit of tweaks that we made to Airflow, so that that would also give a sense of what we were doing over here. So, Airflow stopped supporting the Mesos executor and was promoting the Kubernetes for better reasons. But in PayPal, our entire infrastructure on cloud was built using Mesos for various reasons. And suddenly, because I'm bringing Airflow into picture, I won't be able to change it such a way that I bring Kubernetes into the platform and then start supporting it. So that was a very bigger change in the entire infra region that we want, that was supposed to happen if at all we wanted to use Kubernetes. So what we essentially did was to trigger a Mesos wrapper from our Airflow workers, where the actual job will be executed in the Mesos cluster. In this case, the worker would just act as a router that will invoke the Mesos APIs to do the job. We achieved this by adding a custom operator for this particular need. But this also gave us a flexibility to run the jobs locally by those workers, as well as run them on cloud due to any other security or other dependencies. A point to be noted over here is we didn't provision the schedulers or the workers as a part of the Mesos clusters, and it is just that we wanted to do the actual job execution over there. Apart from that, what we did was, as I was mentioning, there was some network attached storage that will have the tags and the logs associated to it. So we had a log stash that will actually pump the logs into the Elasticsearch cluster, and also the job statuses that are being published for to the Kafka queue, where you have a wide range of consumers for it who can associate their particular job to a given application and take some actions around it. So a little bit deeper on the log stash thing that we wanted to do was any other, like, this is a configuration to Elasticsearch for logs that we did, and basically you can push it into any other log system for that matter, that will help you to effectively visualize what is happening in the system. So, moving forward, I would like to talk about the importance of APIs, where, from a technical standpoint, is that they allow capabilities of one computer program to be used by the another. And there are means by which two different programmers are able to communicate, and that's how you're able to play Spotify within your Uber app or pay via PayPal for your Uber trips or whatnot. So, different entities start to come together to achieve a business outcome. And Apache Airflow's plugin manager allows you to write some custom Airflow plugins, operators, hooks, sensors, and interfaces, where we can piggyback on the existing web based Flask frameworks to expose some APIs related to Airflow or to workflow management. And so plugins was something, as you might know, like coming up in 2.0, which we are also excitedly waiting for, and then also planning to contribute a few of what we built. So APIs were something that was very critical, as we wanted to make the system interoperable with the other domains that we have. And it wasn't always possible to use the CLI or place your DAG files over here and there, which was more cumbersome for the loads that I was talking about. So what we did was we just bucketized the APIs under three major category when we started to envision this, and then it was more of job scheduling, job management, and job monitoring. So these were the three major buckets across where our APIs were spun across, and then started building around each of those categories. So, what does job scheduling mean? We wanted a API that could actually schedule a DAG in Airflow, and that was the ultimate purpose of it. If the DAG is available, if the DAG code is available in GitHub, and when they call our Airflow APIs, we will scrape the code from GitHub and place it in our shared file system. By maintaining this in GitHub, We do have a golden copy and a version control that is already in place as well. And as we split the DAG file into two parts, task definitions and schedule files, the schedule file will be imported into the actual DAG file. So if at all there is any change that is made to a schedule, then we might need to touch and deploy the schedule file instead of the entire DAG file. This API was very useful to us because anyone can just hit the web server endpoint with a post request, and the DAG path will take care of scheduling it for them. So this was the very first API that we wanted to venture with respect to which we called it as a deploy API or a job scheduling one. And the other major things, that one of the critical things was job management. The moment a DAG is scheduled and running in life, there could be many points where we need to perform some management operations on the top of it. So the first thing is to trigger a DAG. This is available via CLI and also the experimental REST APIs that is there. While I was talking about this, an obvious question that would have cropped up in your mind is, hey, there is always also this REST API plugin that is available for APIs. Can I just go ahead and then reuse it? So two things there. First, the response format of this is the standard of the REST API plugin is the standard output logs, where you might have to do some extra processing on the top of it and then send it out in like emit it out in such a way that you will get a proper JSON response. Also, we needed some additional parameters in the request and the response, where building our own APIs were much simpler in cases like these. We need a, and the another main reason was we needed a capability to trigger a task instead of the entire DAG, which is not available out of the box in the UI option that you could see, where people might just come ahead and then say, hey, I have some 20 task instances, but I would just want to trigger one of them. So cases like these was very predominant for the set of use cases that I initially spoke about. And pause or unpause. So essentially, we needed a way to enable or disable a DAG on demand, which was possible for us to do with these APIs. Now, here comes a very interesting feature or something that became very mandatory for us before we wanted to move any of the workflows to Airflow. That is basically hold a workflow from execution or hold a particular task or a job from execution. This is because suddenly there could be some upstream or downstream dependencies that are going for a maintenance. Say my Hadoop cluster is like going for a 1 hour maintenance or things like that, or my upstream, the file that I was waiting for is not yet placed. Could be infra issues or could be logic issues or could be tons of other reasons, where our users will just come and say, hey, I want to hold a job from 3 p.m. to 5 p.m. tomorrow, where the DAG task should not run during that interval. As we could see in Airflow, an entry is only made in a DB when the schedule matches, and there was no option for you to actually change or manipulate the state of a DAG that is destined to run in the future. So this is something that you can still achieve with the help of sensors and variables, but that wasn't scaling enough for the large kind of workloads that we have. And when we have some more number of concurrent users who want to perform a bulk hold or a bulk free operation, essentially they give you some futuristic timestamp and then say, I don't want to run it from this time to this time for X number of reasons. So that was one of the requirements that we had. So what we did was, the moment a hold DAG request is made, we will create another temporary dummy DAG that is scheduled to execute on the time frame that the user has mentioned. This dummy DAG will actually change the state of the actual DAG to be on hold, and it releases it once the time frame is once the time frame passes. So basically, that is scheduling another DAG in a future for a future time when you receive a request and then change the state accordingly. So in this way, we were able to put the jobs in hold for future executions as well. And also this was applicable at a task level for a given DAG. So that was something that was very unique, which was supported by the other schedulers and was mandated as we moved to Airflow, and something that has to be in caution too. Another interesting requirement was when someone wanted to change the parameters for a given DAG. Say, for example, they generally pass a couple of financial instruments to their DAG, and suddenly it has failed for some reasons. Now, they want to rerun that particular instance of a DAG run with a new set of parameters or a new set of financial instruments, basically, so that they can reconcile their data. What does that mean? We should not be changing the DAG parameters, but just for that one single execution, we need to pass it on with some new arguments. So again, we had to make something, use some session objects here. Uh, I heard some background noise. Is it, okay, better. So Oh, okay. And again, we had to use some session objects and modify the states so that this particular outcome can be achieved. So this is something with respect to modify your DAG parameters dynamically can be achieved via Jinja templates and few other aspects as well. But this is something that was one of the requirements. And essentially killing a job that has been stuck or you don't want that to be executed, you set them to fail, like whatever that you see as mark as success, mark as failed. You like as and when you start to talk about APIs that people could start to integrate with, this becomes one of the key feature for it. And then the next thing is job monitoring. For every post, there is a get. So, for any changes that you have done in the system, we also expose some monitoring APIs that customers can query to take some meaningful actions for their jobs. Ours is a truly multi tenant environment, and henceforth, each user might have a different requirement to handle their success and failure use cases. So this is about the monitoring plugins and the list of APIs that we built on the scheduling, management, and monitoring sites that will give a very complete picture on some of the basic systems that one would need to essentially integrate with your scheduler as your service. So that's about the APIs. And as we talk about Airflow plugins, so there are also these operators, and late now there is another best practice that is being suggested where it essentially doesn't need to be a part of the plugins by itself, where you can just write your own operators as the rest of the ones are. So now digging deeper on what exactly did we do for like, or a few operators that was very useful to us is the job status notification operator, where we made use of the on success and on failure callback offered at the dark and task level. So what we pass is the context to this operator by specifying that provide context equal to true, and then we read the requisites like job name, run ID, whatnot, and then publish a message to Kafka, which is a distributed key queue. In that case, we had more than one consumer for this data. So we started publishing the data to the queues so that our producer and consumer can scale and fail independently. It will enforce a truly async communication that will provide so much flexibility on either ends to determine the velocity of publish or consume based on whatever the sources that they had. The next thing that we came up with was a Spark operator that will let you do Spark submits via this. So there are some existing Airflow Spark operators as well that are available, but we wanted to make some tweaks to the total executor cores or the executor memory, driver memory based on the kind of system that you have. So this is just to give a perspective on here, like if there is an operator that is already out there, but if you still want some additional enhancements to be made, you can just go ahead, touch it, and then configure it in a way that is useful for your R workloads. Now, while you can establish a connection to Teradata using some JDBC drivers, it becomes very simple if you could have a custom operator that is designed for your customizations and make the job simpler and better. The last thing is obviously the mesos operator, as I was showing in one of the previous slide, where we wanted to use mesos for our execution. This could actually translate to a executor that we already have it out there, but executors are the one that will pick up and run the job locally. Here we just have a pool of workers that are going to route your traffic to another cluster with a set of APIs. So that's how we came up with something called as a mesos operator, where your workers will just be proxy nodes that will keep routing the request to Mesos via an API call. And as always, security is our top priority at PayPal, where authentication and authorization becomes very critical for every operation that is being made. So Airflow also offers RBAC when we went ahead and then some custom where we had to build some custom mechanisms to verify who the user is and also see what are the resources that he or she will have access to. In this way, we are restricting the access to critical resources that are present as a part of our system. So that is one of a critical thing that you might need to consider as you start to think about your APIs or the other operators that you build in your platform. Now, we are having some existing schedulers like Control M and Music4. We wanted to migrate them to Airflow, and obviously, we won't be able to do it one by one. With the help of Airflow APIs that we made, we ensured that the functionalities have a parity between those schedulers. But we wanted to have a translator that can actually convert the job definitions to DAGs automatically instead of doing it by ourselves. So this was something that is not available out of the box, and then we had to build something like like the Control M and Music for have XML job definitions, where we from the XML tree we had to populate a graph, and once you have a graph, so basically a directed acyclic graph or data structure, it's very simple to again translate them to a custom DAX like how you want. But this is some translators that we built along the course of the journey, and that is about how we are ensuring that the migration happens from the existing ones to Airflow. So, as we develop this, it is also important to keep in mind that we might also need a rollback framework just in case you land into some unexpected issues during your migration. Because the same pipe, like we can just run the same pipeline in the previous scheduler just to eliminate if you have any differences because of your infra issue or scheduler issue or whatever could be. So that is also something that might come into picture when you think about migrating the existing workloads. While anything that starts new will become very simple to go ahead with Airflow at first place. Now, as we keeping in mind about the time in the interest of time, I would just like to talk about a few best practices, a set of guidelines or ideas that represent the most prudent course of action in for a given business situation. And based on our past experiences, it is very important to have the right level of logging configured, uh, and also instrument the metrics in such a way that we can easily narrow down the problem. That's why we wanted to use Elasticsearch as well, where we can easily find out the root cause of the problems in a much simpler way. So it should report an error condition immediately. This allows the earlier detection of an error, and makes the process of software development very stress-free and unproblematic too. It should provide the maximum useful information out of the data structures and have some easy interpretation around it. So, like, if at all I talk about the best practices, the first thing that I would want to say is, hey, like, as you move to production, just ensure that you have, because logs are something that is like, huh, yeah, it comes, like, let me focus more and more on the functionality. But if at all we land into cases where suddenly your DAG isn't running at the time you want to, or you are seeing a 503 from your deployment API, or factors like parallelism and DAG concurrency are something that needs to be monitored very closely. And you could also have some levels of logging put up over here so that we'll have a very clear picture on what is being happening, especially when you have some subdags into picture and have some queues and pools configured for it. Essentially, for people maybe who are very new to this concept of parallelism over here, it just determines how many task instances can be actively running in parallel across the DAX given the resources available at any given point of time. And what is, so if that is it, what does that concurrency mean? So that actually determines how many task instances your scheduler is able to schedule at once at per DAG level. So these are some two factors that you will have to do it on. Like for us, it was more like a trial and error basis because we had multiple such Airflow clusters. But as you start with, you can pick up one, try to maintain it with the defaults, and then depending on your performance or your scheduler latencies, these are some parameters that you could change. At the same time, speaking about the crux of the problem, ensure that we could also log it in such a way that we will be able to accurately determine what the problem is. The next thing, like the very crucial thing, is DAGs, what to have and what not to have. So Apache Airflow has this scheduler process which keeps executing the Python DAG files in the directory to check for the new task that needs to be scheduled or executed. So take absolute care of not writing any redundant code other than the operator definition and probably a dependency statement in the DAG file. For example, If you have a code snippet for downloading a config file from a remote location outside an operator, then this snippet will be executed every time a scheduler is every time when a scheduler process is active, and then it can lead to some unexpected side effects. The next thing is, like, it's always better to use operators for any additional activities that you want to do. And with respect to DAX, just like how I was talking about importing your dependencies, it is always the best practice to keep your business logic away from DAGs. Whatever that you want to do, handle it as a part of your script or callable that you have, and DAG is just more like a workflow definition. While it gives you all the flexibility to do it, it's always a best practice to not do it. And embrace skills where you have to ensure that your DAGs are small and simple, as simple as possible actually, and as small as possible too. The idea is that the DAG should contain only tasks that are truly dependent on each other. Tasks that are similar in nature but don't depend on each other should be kept in separate DAGs, as they allow some small bugs or works that are easily extendable. And linking unrelated tasks is a technical debt that could be a painful thing to be, which we need to pay off later. Now, as I'm going to the towards the end, it's about the tasks and what to have and what not to have. So idempotency is a key thing, because there can be failures that might end up having, and all that we if your tasks are not idempotent, or if you don't advise the integrations to like your customers to ensure that it is idempotent, we will end up clearing up all the data that is already inserted into your table, or like whatever happened, the partial thing that we need to do as a part of data correction. The second thing is to keep a watch on the volume of data that is being brought into memory. So basically, we were facing some issues where, with respect to Spark jobs, where your task instance has been assigned some amount of memory, but one of the jobs was trying to overload all of the jobs and creating some production issues here and there. Another powerful thing that I would recommend is to always watch out for this wait for downstream option, where you could set up some conditions like when you establish dependencies between your tasks, and then you can say, hey, like, wait until this gets completed. And the one of the other good practices, or the one that we have been using extensively, is to start using the Jinja templates that are available. Probably people might just overlook it when they just start with putting a couple of basic DAX that we are there. But as I wanted to focus more on productionizing things, so that is something that we could make use of extensively, so that it comes very handy when we scale the system. So that's about what I had. Thanks everyone, and hope you liked the session and have something to take away as well. I would be open to questions now.
Hey, thanks a lot, Aishwarya. It was really awesome to know the use cases and the solutions you guys have built over to solve them. I really think that it will be very helpful for the audience here. I think we have like 5 or 6 minutes left, so I would like to give this time to our audience to ask us any questions they have. And I got a couple of questions, so we can start with the first question. Um, so the first question is about have you hit issues with the scheduler scaling, and how did you solve those issues? Considering that you have 100K plus jobs running in the cluster. So yeah,
Got
question is about the scaling of the scheduler. Yeah.
Got it. Hey, thanks for that question. Yeah, that is probably one of the biggest challenges that we face too. So all of these, so that was on the clustering side that I actually put up. So what we did was, obviously we had scheduler latency when we kept adding more workers to the system, and that would depend based on the kind. So we started with having 30 workers with a monster skew scheduler bare metal as in a physical host instead of having a cloud VM. But then, like, if I schedule a job for 2.5, it will be scheduling it for 2.20 because of so many X reasons where the your pools get piled up. In that case, our the way we approach this problem was that there could be it is a problem that is there, but how could we go ahead and then solve it? Is basically cluster the airflow instances and reduce the load on the cluster. So you put your critical workloads in one cluster, which has very minimal number of jobs accurate. and then you have another cluster that is out there with low latency requirements and things like that. So scheduler scaling is something that you cannot do, like how add one more scheduler and then it will just work, is not how it works here, right? So like there are talks about having some in 2.0 where you have more than one scheduler that is planning to come up. But today, the as such, there is no concept of scheduler scaling by itself, but basically splitting is all that we were able to do as a part of this exercise that we did. That's what I
Okay.
had. Sure.
Yeah, great, great. Okay, the second question is about the scheduler failover, and
Okay.
the question is that are you using the Clariovent solution? So I think the Clariovent is a company or a there's a
Hmm.
GitHub repo I think, and they have some scripts about the maintenance, DEG maintenance or things like that. Yeah,
Got it. Yeah.
are you aware about that?
Yeah, I do. So basically, we before we wanted to write our own script, we were checking out the Clarion. I think the last time that it was committed was over some 11 months back or so. So basically, if you want to have the latest Airflow running and then trying to make use of that script, we were facing some issues where the one of the main thing, or in leaving apart the issues, so say for example you have to probe on the number of active requests that are being made. Basically you want to handle see, hey, what is my current scheduler load, what are the list of tasks that are going to be scheduled for next 5 minutes or so, and then do a graceful stop of your scheduler. That is something that wasn't like available out of the box with that Clarion thing, and then it made more sense where essentially it's a failover system that you have, and then it basically looks out for a scheduler heartbeat. So one that we made use of is the, if you look into one of the Airflow APIs by itself, they would provide you the last heartbeat of your scheduler time. So that's the way this thing response that we took into consideration. Keep a active probe on it, or that's what the UA also actually does, where you see, hey, your last scheduler heartbeat is 30 seconds ago or something like that. So that's the parameter that we have for monitoring, and depending on that we try to go ahead and then restart the scheduler. If it's not available, then switch it to your secondary is what we did. And as we talk about failovers, also ensure that your schedulers are geographically split across locations, so that if you have any data center issues or power outage issues, you will not have your production jobs going for a toss.
Okay, okay, sounds great. Okay, so next question we have is about did you experience any problems and have any hints for the database load?
That's okay. Huh. Okay, that is also one of the problems that we had, where the number of, so basically problems with database load was the number of connections that we make as and when our APIs were scaling. So that was one of the issues that we primarily had. So that we combated by having a load balancer on the top of our MySQL, and then actually scaling the database as well, so that you'll have to read only databases where that could actually serve your traffic. And if the connections that are being made from Airflow is at a point of time limited to 24 when we started with, and then later had to. So there are plans of building some connection buffers that would help you reuse and all of it. But with respect to the APIs that we built, we wanted to do all this connection pooling as we make. With respect to the rights, we were using this managed MySQL, so that wasn't giving a lot of problems with respect to the space or things like that. But connection was one issue that we faced with respect to the database load.
Okay. Okay, quickly, I think we can just take one more question because it's
Okay.
1 minute left. So in your experience, using Redis is the best option to maintain the production environment?
Okay, that actually depends. So we were initially using RabbitMQ. That was just a infra decision that we made. So in my experience, both MQ and Redis both were actually good. Like we have use cases that were moving to Redis, and then like MQ was not being supported at PayPal, and that's why we moved to Redis. And like later, there are also plans of using other in-memory caches that we that is available out there. But like MQ would be my first preference, and then Redis was just another choice that we had. Hey, it works, and then like there is some other team that is going to manage it for us, and that was the reason why we moved. But if you like, I would recommend MQ at first place. But Redis is something that we use in production today, and like you can go ahead and then for sure use it. You just need to configure your parameters accordingly a bit, which I can talk about in the interest of time later. Maybe you can reach out to me. I think the question is from Digo. I can send you a couple of configurations that we did in order to make Redis work at its best in live, Digo.
Okay. Great. So yeah, we are. It was nice to hear from your experience, Aishwarya, and I hope it was very helpful for everybody. And we're just gonna have a break of 15 minutes, and then we're gonna resume from the same link. So the audience, you can stay or you can have a break and come back. And yeah, there are two more awesome talks coming in the line. And thanks you, thanks, Aishwarya.
Thanks, Sumit.
See
Thanks
you
for
all.
hosting this. Bye
Yeah.
bye.